on user. User, am I audible to you? Can someone respond? Hello, am I audible to you? User. Okay, we will wait for 5 minutes if anyone joins or not, or else we will start the class. Uday, am I audible to you? Hello, Uday. Uday, am I audible to you?
Yes, sir.
Okay, okay. We will wait for 10:35.
Yeah, okay, sir.
My screen is visible, right?
Yeah. Yes.
Okay, guys. So, good morning. Is this your first class of the second semester in online?
Yes.
Okay. Um, in the exam point of view, for 6 semesters, this first semester and second semester syllabus are very important. Each and every topic will come in the next semesters in third, fourth, fifth, and sixth. In sixth semester, you need to learn this second semester very thoroughly, or else you will get confused. Okay, regarding this unit to probability mass function, probability density function, and distribution functions. These are the main important. These are the important topics for sixth semester also. Okay, if you learn this first semester and second semester thoroughly, you can get good score in the next semester. Okay, third and fourth mainly depends upon this one and two only. Okay, and probability in this probability. Probability is a very important topic. You will get this probability in 3, 4, 5 in next 4 semesters also. Mainly in sixth semester, you will get confused if you don't go thoroughly in second semester. There will be probability density function, PDF, PMF, PDF, PMF values, and that's it. First, we want to know. Yeah, I think you have learned these probabilities in your inter or 10th class also, right? Can anyone have the idea about probability? Guys, can anyone have idea about the probability? Someone respond. If yes, yes. If no, no. Why do we use probability? If you don't interact, you won't get anything. Okay? Tell me no problem if it is wrong also. But respond. We use probability to know the outcomes, whether it is how much outcome is coming. If we toss a coin, there will be heads and tails, right? There are only two options. 50-50. We will get either head, either tail. We know the percentage of getting head also, percentage of getting tail also. That is a probability. For what? For those we use these random variables, discrete and continuous random variables. This all type. We will see. Introduction. In statistical problems, we are concerned with one number or a few numbers which are associated with the outcomes of experiments. Here, see. In experiments, we can get one result or two results or maybe multiple results. Okay. So, what is the probability of getting that result? We need to calculate, right? So if we take that example of tossing a coin, we have two results. Okay, or one is head, one is tail, right? There are two outcomes. In sometimes, if we throw two coins, we'll get around head, tail, and tail head. We get four outcomes. Okay, we want to know the probability of getting head of one head or two head or three head or like that. Okay, for this first we need to know what are the variables, what are the guys, can you all mute? Spandana, can you mute your Spandana and user? Okay. We want to know about random variables. Okay. What is a constant? A constant is a quantity which has unique value. It won't change irrespective of the problem. Constant. What is variable? Variable is a quantity which varies or changes from one value to another value. The changes may occur due to time factor or any factor. Okay. Variable. What is a constant? Constant has a unique value. It does not change with any situation in the problem. But variable, it can change. Suppose we take x equal to 0. Suppose we have uh, tossing a tossing two coins. In that condition, we had a head and tail, right? We are taking head as a variable. Okay, taking head as a variable. What are the four values we will get? Head, tail, and tail, right? In this, if we are taking head as a variable, here you can take x let head equal to x. Okay, x equal to 0 means there is no head. X equal to 1 means there is only one head. X equal to 2 means there is only in there are two heads. Okay, this is a variable that's constant. Okay, next variable can be discrete or continuous. What is discrete variable? Discrete random variable takes only certain values in a range. For example, number of dice, number of children in a family, then can take only integral values. See, it is discrete variable, takes only certain values in a range. For example, dice. In dice, how many values will be there? Six, right? It won't change or it won't decrease, right? It can be countable. And six. Next, number of children in a family. Number of children in a family only taken from integral values. We can count like example 5, 6, 7 or like that, right? But in continuous variable, we will take all possible values in its range. For example, this one. Here, take some example. Height and weight of a person. Can take any value in certain. Okay, if we take some 10%, okay, everyone's height will be different, right? Someone start from 5 feet to 6 feet. We suppose we take. Okay, here there is a range. What 5 feet to 6 feet. But in between there can be any value 5.2, 5.3, 5.7 or like that. For that one we use continuous variable. Next, a random variable. A variable x is said to be a random variable which takes values randomly. So see, a random variable is a function that assigns a real number to the sample point in the sample space of a random experiment. Let x be a random variable. We are taking some random in a larger expression. We will take x is an random variable. Suppose you can take we have taken only 2 dice, 3 dice, right? We will take n dice. In that place, we don't know the probability. So that's why we use this random variable to look at. Suppose in n dice we want to know about the sixth head. Okay, we don't know. So we will take this type of random variables. X, a real valued function x defined on sample space of S of a random experiment. So that sample space of S. What is sample space? We'll discuss. Sample space means the amount of getting. Suppose we have taken 2 days. Okay, in the 1 days we only have two sample space. What is one means head and tail, only two, right? If we take head equal to 1, head equal to 1, head equal to w1 equal to h, w2 equal to t, right? This is not the sample space example, but I am telling for you only. Here w1 and w2, what is that? Head and tail. Okay, if a coin is tossed, then s is the sample space. Okay, w1 w, there are two outcomes. What is one? What one is head, one is tail. If we take two coins, then what is the sample space? Can anyone tell? Can anyone tell what is the sample space if we had taken two coins? Here the sample space is head, tail, head tail, and tail tail. There are four, right? There are four. Then we know we need to know about the probability of getting head. Then what we can do? 0, 1, 2, because there will be no zeros, no heads, or only one head, or only two heads. Okay, that's it. Next, Bennon is random variable. Bennon, if a coin is tossed, then S equal to W1 comma W2, where W1 is the head, W2 is the tail. Okay, these are the outcomes, right? Head and tail. If one coin is tossed, so that X of W is 1 if W equal to H, 0 if W equal to T. Why W equal to H equal to 1? Why W equal to T equal to 0? We are taking W equal to H X of W equal to 1. If T, H equal to 0, right? So that's why 0. If we only take either heads or tails, you can see. XOR is a Bernoulli random. XOR can take only two values, or either 1 or 0. If you take head, you can get head or no head. You can get tail or no tail. Okay, 1 means head, 0 means no head. The random variable sticks. Okay, next. For examination point of view, these are main important definitions for first bit, 5 marks. Next, discrete random variable. Types of random variables. There are two types: discrete random variable and continuous random variable. What is discrete random variable? Discrete random. If a random variable x takes at most a countable number of values, it is called discrete random variable. In other words, a real value function defined on a discrete sample space equal. Here we can see what is what we had learned here. Discrete variable takes a finite only certain values in a range, right? Yes, see. Yes, see. For example, number of children in a family. We can count it within the range. Next second one also. Number of students in a class. These are certain values in a range. Discrete random variable. What is continuous random variable? Yes, you can see. Continuous random variable. Let's see the example first. After that, here the temperature recorded in a town. Okay, in a town there will be a different temperature at different places, right? So we will segregate this one into a range. Something. Second one, age of a group of a person. If in group of 10%, a group of 10%, some will have everyone will have different ages, right? There will be a range here also. You see, a random variable x is said to be continuous. It takes all the possible values between the certain constants. See, okay, the age must be start between 50 to 75. The 50 and 75 are certain constants, but in the middle it takes all the possible values. Some will be 60, some will be 65, like that. Here also, height of the soldiers in the country, life of an electric bulb in hours. The definitions of continuous random variable and discrete random variable are very important for your final examinations. Let's see. Yes, see. 1.4.2. If we can toss a fake coin, find the sample space and range of the random variable. If you toss a coin, what will be the sample space? Head and tail. Only two outcomes, right? See, if we toss a fair coin, sample space will be head and tail. Okay. Consider random variable x, which assigns to each element of the S the number of head in that element that x of sample space belongs to, or the real number is given by x of h equal to t, x of t equal to 0. Here, number of heads equal to, what is the range of x? What is the range? 0 comma 1 only, because num if only two outcomes, right? S equal to, see here, s equal to h comma t, only two outcomes. For h, for the first one it will be 1, in second one it will be 0, 0 comma 1. For tails also, you can see this will be 0 and this will be 1. Okay, so the range of x is 0 comma 1. So here sample space is h comma t and the range of the x is 0 comma 1. Hence x can take the values of 0 comma 1. You see another one. Here when a die can throw, here if we can throw a die, then a random variable is defined as the number of pairs. Find the sample space and the probability function. Now we throw a dice, what will be the outcome? Anything, 1, 2, 3, 4, 5, 6. In the six numbers, anything can be the outcome. But the number of possible outcomes is 1, 2, 3, 4, 5, 6. 6, right? Next. What is the range of x? Range of x also 1, 2, 3, 4, 5, 6. Why? Every time we can get one number. Either 1, 2, 3, 4, 5, 6. Number of numbers in the dice is 1, 2, 3, 4, 5, 6. The sample space. Okay. Now you can see Here x can take the values of 1, 2, 3, 4, 5, 6. Okay. Now, what is the probability function? Probability function of x, p of x equal to 1 is defined as p of 1 equal to 1 by 6. In total of 6 numbers, one can be uh, one can be rolled one time only, right? I mean, if we throw it, one will be on one side only, right? In the dice. 1 by 6, p of 2 equal to 1 by 6, p of 3 equal to 1 by 6. There are single values. P of 4, p of 5, p of 6. If you see here, outcome is 1. Random variable is 1. You get p of x equal to 1 by 6. Here 6 is the sample space. How many 6? How many values? 6, right? Total? 1, 2, 3, 4, 5, 6. Total of 6 values by someone will ask, sir, p of 2 equal to 2 by 6. No, not like that. P of 2 is how many 2s are this in a dice? Only 1, 2, right? We have 2 2s. We'll do like that. We in dice we'll only get 1, 2, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? So that's why only one will be repeated. One will be there in the dice. So the 1 by 6, 1 by 6, 1 by 6. The sum of the probability P of x equal to x is there, right? For 1 to 6 will be 1. Remember, whenever you do a problem, here P of x equal to x, right? This all value, if we add all these values, it should be 1. Okay, the probability of any value, any function will be equal to 1. If it gets greater than 1, you are doing a wrong problem. Okay, you made a mistake. It won't be greater than 1. It will be equal to 1. When this p of x equal to x values are there, right? If we add all these values, you need to get 1. Not less than 1, not greater than 1. Okay, remember, this is the main point. P of x equal to x for any function is equal to 1. If we add this 1 by 6, 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 we will get 1 only. Because 6 by 6 equal to 1, right? Okay, now we will discuss about this secure progress problems. If we can toss a fair if we can toss a fair coin, find the sample space range of the variable and the probability function. The probability function. What if can anyone tell me the sample space? Guys, respond. Can anyone tell me the sample space? Uday, Spandana, user, Abhinaya, Anjali. Can anyone?
Four subjects.
What are those, Uday?
Head, head, tail, tail, head, tail, tail out.
Yeah, okay. That is a sample space of four. Four, right? Head, head, tail. Okay. What is the range of the random variable? Can anyone? Range of the random variable. What is the range of the random variable of this problem? Let's take head. Okay. Let x be the head. Tell me no. Can anyone?
0 to 1.
0,
0, 1, 1,
0, 1.
2.
Yeah. How did you get?
Head has one, so both heads will do
Okay.
2.
We can have two heads. We can have one head, or or no heads, right? So that's why 0, 1, 2. Okay. Next, the probability function for a p of x equal to 0, p of x equal to 1, and p of x equal to 2. Can anyone tell? We got the range 0, 1, 2, right? So we need to find the probability function. P of x equal to 0, p of x equal to 1, p of x equal to 2. Can anyone try? తప్పైనా పర్లేదు చెప్పండి. ఒక్కళ్ళన్నా ట్రై చేయండి.
X is equal to 0, 1 by 4.
Pardon?
X is equal to 0, 1 by 4.
Okay, right.
Because two tails
Oh,
are there and it's only
okay. Next, p of x equal to 1,
it's 1 by 2.
1 by
2.
how did you get it?
In two places we have that specially.
Yeah,
Tails.
yeah,
So 1 by 4 plus 1 by 4, it's 1 by 2.
yeah, correct. Next, p of x equal to 2, అమ్మా
By 2.
1 by
1 by 2, sir.
1 by 2 ఎలా?
Into 2, sir.
The voice is disturbing.
2 heads, sir. It into 1.
P of x equal to 0 is 1 by 4. P of x equal to 1 is 1 by 2. P of x equal to 2,
1 by 2, sir.
1 by 4. Because P of x equal to 0 means there are no heads. No heads means only tails and tails, right? That is only 1. So 1 by number sample space, what? 1 by 4. Okay. P of x equal to 1 means only one head, any one head. Head to tail, tail head. So we have 2. 1 by 4 plus 1 by 4. So that we can get 1 by 2. So P of x equal to 2 means 2 heads. 2 heads, how many are there? Only one there, right? That is 1 by sample space, 1 by 4. That is a probability function. You can check it. Here you can see in the what page number? In page number 8, if you see one,
193.
wait. There are some mistakes in this textbook. If you add 1 by 4 plus 1 by 2 plus 1 by 2, how much you will get? It will be 1.25, right? But what I said, probability of any function would be equal to 1 only, right? Here it's a printing mistake. This is 1 by 4. Okay, change it. I have seen this, and so that's why I have asked you what is the probability of p of x equal to 2. This is 1 by 4. Change it. There are some mistakes we need to rectify. Can anyone tell me about the second problem? If we can toss a pair coin thrice, what is the sample space? Can anyone?
Eight, sir.
Can tell the sample spaces?
head, tail,
Okay.
tail, 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 head, head, sir.
Okay. In this tossing a coin, you need to know a simple logic. If you are tossing one coin, okay, the number of sample space is 2 power 1. If we 2 power n is the if you are tossing n number of coins, okay, the sample space will be 2 power n. For one coin, you will get 2 power 1 2. For two coins, you will get 2 power 2 4. Three coins, you will get 2 power 3. Means 8 variables, 8 sample spaces. Okay.
Yes.
Okay. Okay.
Okay, sir.
Now, can anyone tell of the range of the random variables? You are taking the random variable of head. Let's take x. Head is a random variable. Now tell me the no, not head. You know now you can take the tail. Okay. Tell me about the range of the random variable.
3, 2, 1, 0, 1, 2, 3, sir.
Okay. And now the probability function. Probability function of p of x equal to 0, x equal to 1, x equal to 2, x equal to 3.
X equal to 0 వచ్చేసి 1/8, sir.
Okay.
Is equal to 1 వచ్చేసి 3/8, sir.
X equal to 1 is
3/8.
okay. How did you get that?
అంటే 2 హెడ్స్ వచ్చేసి 3 ఉన్నాయి సార్, అంతే అవి శాంపుల్ స్పేస్. హెడ్, టేలు, టేలు, హెడ్.
Okay. Okay. 1 by 8 plus 1 by 8 plus 1 by 8. 3 by 8. Next, p of x equal to 2.
ఇవి కూడా
P of x equal to 2.
3/8, sir.
Okay. 3 by 8. Okay. P of x equal to 3.
1/8, sir. 1
Okay.
and 1
మీరు
హెడ్.
చేసినప్పుడు కరెక్టా కాదని ఎలా తెలుసుకుంటారు?
అంటే ఇప్పుడు ఎక్స్ ఈక్వల్ 2 అన్నారు కాబట్టి హెడ్ 2 ఉండేటి మనం చూస్తాం సార్. అప్పుడు హెడ్ టేల్ వస్తుంది, హెడ్ టేల్, హెడ్.
ఓకే. ఇప్పుడు ఈ ప్రాబబిలిటీస్ అన్నిటిని యాడ్ చేస్తే మీకు 1 వస్తుందా?
Yes.
1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8.
వస్తుంది సార్.
ఓకే. అంటే మీరు కరెక్ట్ చేస్తారని.
వస్తుంది సార్. 3 ప్లస్ 1/8 వస్తుంది సార్. అప్పుడు 8/8 వచ్చేసి 1, సార్.
Can anyone do this 1.56 problem? Sixth problem, what is the random variable? In sixth column, if we
శాంపుల్
can
వచ్చేసి 36 సార్.
wait. If we can throw a pair of dice in a random experiment, find the sample space and the probability function. Okay. And the random variable
శాంపుల్
defined as the sum of the numbers. Okay. In
ఎస్
two dices, what is the range? Two dices here x is defined as the sum of the numbers, right?
ఎస్ సార్.
Means in two dices there will be 1 and 1. What is 1 plus 1? 2. That is at least. What is the at most? 2? 6 plus 6, 12, right? From 2
ఎస్
to
సార్.
12 means p of x equal to 2, p of x equal to 3, so on, p of x equal to 12. Okay.
ఎస్ సార్.
ఇక్కడ మీకు రేంజ్ వచ్చేసి 2 నుంచి 12 వరకు ఉంటుంది. ఎందుకు? ఇక్కడ ర్యాండమ్ వేరు మనకి ఏది ఇచ్చాడు? సమ్ ఆఫ్ ద నెంబర్స్ అని ఇచ్చాడు. సమ్ ఆఫ్ ద నెంబర్స్ ఏముంటాయి రెండు డైస్ మీద? 1 ప్లస్ 1 ఉండొచ్చు, 1 ప్లస్ 2 ఉండొచ్చు, 1 ప్లస్ 3 ఉండొచ్చు, 6 ప్లస్ 6 ఉండొచ్చు, 6 ప్లస్ 5 ఉండొచ్చు, 5 ప్లస్ 5 ఉండొచ్చు కదా. మీకు ఎక్కడి నుంచి వస్తుంది?
Yes.
మాక్సిమం నెంబర్ రెండిట్లో 6, మినిమం నెంబర్ రెండిట్లో 1. సో 2 నుంచి 12 వరకు ఉంటుంది. ఓకేనా? ఇప్పుడు 2 తీసుకున్నాం. 2కి ఏమొస్తుంది? ఓన్లీ 1 ప్లస్ 1 మాత్రమే వస్తుంది, రైట్? ఇప్పుడు
1/36.
ఎంత? 36. అప్పుడు
Yes,
1/36 p of x equal to 2. p of x equal to 3 చెప్పండి ఎవరైనా.
2/1 వస్తుంది.
2/36.
1/2 వస్తుంది సార్.
2/36.
2/36 అంటే 1/12.
ఒకసారి అన్నిటికి చెప్తారా చేసి? వి హ్యాడ్ టైం. Not only Uday and Spandana, everyone should interact. Abhinaya and Anjali also. P of x equal to 4.
Three 36.
P of x equal to 3.
3/36.
X equal to 3. 3/36.
Yes, sir.
How can you get 1, 2 and 2, 1 only, right? Only 2.
4 అసలు చెప్పింది నేను ఇప్పుడు.
మీరు 4 చెప్పారు. ఇప్పుడు P of x equal to 4 కి చెప్పారా?
Yes, sir.
1, 3, 3, 1, 2, 2. 3/36. Okay. P of x equal to 5.
4/36. 4 ఉన్నాయి సార్.
5 కా? 1,
Yes,
4, 4, 1, 3, 2, 2, 3. Okay, 4/36. P of x equal to 6.
5 ఉన్నాయి సార్. 1, 5, 2, 4,
1,
3,
5, 2,
3,
4, 3, 3, 4, 2,
3,
5, 1.
4, 2, 5, 1.
5/36.
Yes, sir.
Okay. In this way you need to do this problem. ఎక్కడ దాకా?
Yes.
మొత్తం 12. P of x equal to 12 వరకు. ఓకే. చేశారు 6th మొత్తం అందరూ? ఫుల్ గా చేస్తే మీకు ఇంకోటి ఇందులోనే చెప్పాలి. 2 నుంచి 12 వరకు చేస్తే మీకు చెప్పగలను.
P of 7 is equal to 6, sir. 6/36.
ఓకే.
P of 8 వచ్చేసి 7. P of 8 వచ్చేసి 5, sir. P of 9 4, P of 10 2, P of 11 2, sir. P of 12 వచ్చేసి 1.
P of 10
3, sir.
3.
P of 11 2, P of 12 1, sir.
ఓకే, ఇవన్నీ యాడ్ చేస్తే మీకు ప్రాబిలిటీ 1 వస్తుందా? చూసుకున్నారా?
Yes.
Three, 6, 10, 15, 3, 6, 10. వస్తుంది సార్.
ఓకే, కరెక్ట్. ఇక్కడ చూడండి. If they ask, we need to calculate the value of P of x. P of x less than or equal to 3. Okay, if they ask calculate the value of P of x less than or equal to 3, then we need to calculate less than or equal to 3, right? So we need to calculate P of x equal to 0, P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3. We need to calculate if P of x less than or equal to 3. Okay, here there is no 0, right? So we will start from p of x equal to 1. Can anyone tell p of x less than or equal to 3 in this?
3 by 6.
3 by 6. Okay. P of x less than or equal to 5.
5 by 6.
Okay. What we have done, 1, 2, 3, 4, 5, 6, we added like that, right?
Yes.
But if we know p of x less than or equal to 5 and 6 is the last number, right? But we know the value of 6 also. Probability value of p of x equal to 6 also. What is the total probability? 1, right?
1 minus 1 by 6 once
1
again.
minus 1 by 6 will be 5 by 6. Okay. P of x. If we want to know the values of p of x x equal to p of 2 less than or equal to x less than or equal to 4 means p of 2 less than or equal to x less than or equal to 4.
3 by 6.
How?
You take 2 value, 3 value, 4 value. 1 by 6 plus
Between
1 by
the
6
values
plus
of
1 by
2
6.
to 4, right? 2, 3, 4 because we use less than or equal to. So 2, 3, 4. 2 1 by 6 plus 1 by 6 plus 1 by 6. Now you need to do for this one, sixth one. Okay. This one. Here in this sixth one, you need to do a three problems. Okay. P of x less than or equal to 7. First one, write down P of x less than or equal to 7. Next, P of x, P of 5 less than or equal to x less than or equal to 9. Okay. Next, P of x less than 7. Only less than. Next, P of x greater than 10. You do this fourth one and let me know. చేశారా?
Yes.
First question is P of x less than or equal to 5.
Less than or equal to 7.
Less than or equal to 7.
21/36.
The second one, in this unit, these definitions are very important. So they look small, but see, in the second unit, probability mass function, probability density function, probability distribution function. These three are very much important for your next semesters also. Mainly PMF, PDF. It would get tough if you don't go thoroughly through this second semester.
Four by 36.
For what? 4?
24/36.
Question. P of?
5 less than or equal to x less than or equal to 9.
Okay.
X less than 7, 15 by 36.
Okay.
X greater than 10, 3 by 36.
P of x equal to 11.
2 by 36.
Okay. P of x equal to 12.
1 by
1 by
36.
1 by 36. Okay. So 3 by 36. Okay. Any doubts in this?
No.
Yeah, that's it for today. Leave.